Back, everyone. Um, Today we're going to look at hasIn, and hasPath. They're all very closely related, and we may look at head if it doesn't take too long, because these are actually really simple. Um, but side note before we get into that, in the last video, I had all kinds of problems. I was getting confused by the order of greater than and less than far as the order of the arguments. And I also had a problem with group by or group with trying to negate equals. Um, the negation of equals, the reason it wasn't working has to do with the number of arguments the functions were taking. So it can be done using uncurry, which we may not have looked at yet, and inary, which was looked at in the first series by Chris. But I'm prepared to leave that one alone. I think it's not something that comes up quite a bit, but I do want to address the greater than less than. And I understand it was so simple that I was making it complicated. So let's look at greater than. The first thing I said with greater than is it's the this symbol here, right? And the what I was doing is I was confusing myself because when I use this function, I want to check if something is greater than. So like a function called is greater than. And that's what I was thinking this function was, like is greater than. It returns a Boolean, but that's not what it is. It's just the operator. So the simple thing to remember that is, let's say we did r dot greater than 3 and then 4. And I was thinking is greater than 3 and then 4 is the thing. But it says if the first argument is greater than the second. So it's like is 3 greater than this argument? And the way to remember that is just simply move the function to the infix, like in your mind. Then your mind, it would be like r dot greater than 4, right? And of course, that's not valid code, but or take it one step further, is 3 greater than 4? That's what it is. So if you just, we can't use infix notation in JavaScript, but if you could just mentally move the function here. Now, I don't know why. I mean, I guess you would just use that when you wanted to use a function instead of the operator. Um, you know, for whatever reason, you might want to do that. But most of the time, I want to do something like const is greater than, and then, or is greater than 3. And then what I would do is I would take the flip function, apply it to r dot greater than, and then provide 3, which is the second argument, like that. And see how easy that is to read when you separate the arguments, especially when you're currying them, um, or calling a curried function, I should say. And in fact, let me do that down here too. Yeah, I mean, just for me, that's easier to remember or easier to understand. So then if we call that function r dot, oh no, just is greater than 3, and then we do 4, we should get true, and we do. If we do 1, we get false, and we do. So that's the little addendum to the last video. Just remember, it's not is greater than, it's just greater than. It's just the operator. Cool. So we're done with that. And now we are in the H's, and we're going to look at has and hasIn and hasPath. And so I dug into this a little bit last night. It's super simple. JavaScript has a has own property method. that's on the object prototype, and it has been around since 2015, I think. But there's a bit of an issue with it. So let me show you. If we made, we're going to have to go all object oriented here for a second. I'm going to make a class called square. Constructor is going to take a width and a height, and we're going to do this. Oh, I wrote this. I'm sorry. And uh, wait, did I do that? Can't remember how to make a class. Height equals height, right? And then we could instantiate that. I'll call it square lowercase equals the good old new keyword, new square, 32 and 42. And then let's just log that, see what we get. And we get a square with 32, height 42. All right. So we could say r dot has to determine if it has a property. So r dot has width, and then pass the object, right? This way we're calling it both, providing both arguments to the initial function call. And that is true. And if we said height, that is also true. But if I like misspelled it or something, we get false, right? So it just tells you if an object has a property. But it's like returns whether or not an object has its an own property, right? So let's say we added an area method and we return this dot width times this dot height, right? And then, so we could call it like uh, square dot area and invoke it, and we get back a number 1344. Um, so that's working. But then we could say r dot has and pass in area. We want to see if it has a property called area, and we pass it the square. Here, this time let's do it like this. And it's false, right? So the thing is like has own, and there's a new method called has own that was introduced in 2022 that was meant to replace the has own property. Because the has own property, if we had used that, let's do that. Let's just use the native object. I think it's a static method. Object that has own. Let's see. Object has own. Their code example. Nope. All right, pass the object and then pass the property. So has on square and the key of area, and we get false, right? But if we did has own property on a static method, determines whether an object has a property method. Okay, we'll just try it. So we get false. Um, and what did we get when we just did has on? Did we get false there too? Yeah, we got false there two, you know, maybe it's because I'm creating this with a class instead of, people usually make classes with a function and still use the this keyword, but that's okay. This is kind of, I mean, that's the native way. You can go and look into the nuances of that. But the reason we have these functions is because there are nuances that you have to worry about, and we would rather not worry about them. So let's just say R that has on, and arguments are in different order, where, and oh, I made a mistake, has own area. What was the error? R that has, oh, it just has. Yeah, that's false. Okay. So let's just look at this, but we need to look at has in too at the same time. So has takes a string. That's what this S is, I believe. The prop name of the property to check, and object properties are strings. So it takes a string, and then it takes an object, which has a key value pair. So the key is a string, the value is whatever, and then it returns a boolean, true or false. So here we have has name. Uh, let's go back and say width. So we get a true, and we do. And yeah, but if we say area, we get false, right? But if we use as in, now see this function s and then a object with a sx pair returns a boolean. As in has the exact same signature. String, an object with a string value pair or more than one string value pair and returns a boolean. And this one says returns whether or not an object or its prototype chain has a property with the specified name. So the difference is the or its prototype chain. It'll look at that too. So if I do has in, first with just has, we get false for area. But if we change this to has in, we get true. So if you're needing to check whether an object or anything that the object inherits from, like a prototype, um, has in is what you're looking for. But if you want to know if just the object itself has a property, then you use has. And then you can partially apply this like they do in the example. So we could say const has area and do r dot has area, and then just pass the object, and we get false. And then if we made one calls has in area, do both. Oh, I didn't change this to has in. Good old copy paste mistakes. Yeah, false and then true, right? So that's has. Did I miss anything here? Returns whether or not. Is there any useful information here? No. Property to check, object to query, and then true or false. So that's has and has in. And then there's hasPath. And the reason I'm showing this is because I want to look at the code for the other ones. we'll use the same class. Um, this one returns whether or not a path exists in an object. Only the object's own properties are checked, right? So this is more like more related to has than has in. But here we've got this type constraint of the index, and the index is either a string, an int, or a symbol. And we provided an array of indexes, and then, or one or more indexes, and then we provided an object, any object, and it returns a Boolean. And what it's going to do is it's going to, if we want to like check, let's see, you know what, this is going to be easier if I just make a raw object. So we'll just make it a square without using a class. And we'll say width is 32, height is 42. And then let's say colors, and we'll make that an object, and we'll have a primary color, which will be blue, and a secondary color, which will be red. And then we will use r dot as path, and then we could provide it an array, right? An array of indexes, so an array of keys, and then we can say like width, and then pass the square to it. And so we're asking, does the object have a like if you drill down to an object like square dot width, does that exist, right? Even if it's null or undefined, um, just does the property exist on the object? And oh, and this needs to be a string. Cannot find. Oh, I misspelled. Sorry. All right, get myself together. Clear the console. JS. There we go. The width property does belong to the square, so it's sort of like has, right? But this is a path. So like, can we do colors, and then nested in colors? Is there a primary, right? So it's saying like this is like square dot colors dot primary. Um, and that's true. And of course, we could do like square uh, this way, square dot colors dot primary. You know, like we can do that, and that's pretty simple, pretty nice. But if we're using functions instead of operators, we can do it this way. But if we said like other, do we have square dot colors dot other, and then we should get false, and we do. So I'm thinking again, like you do a fetch request, and you get back this crazy object, and maybe you get back different results depending on which input you or endpoint you try to fetch or fetch from, whatever the terminology is. Um, and you might have slightly different shapes, and based on that shape, you want to do something different. So you could, check if it has that path beforehand. Otherwise, you can use that question mark optional chaining if you're just worried about trying to access a value on a property that doesn't exist, whatever you want to do. But what's cool about that is that if you go and look at the code for has, all of this is just documentation, and then it's has, and then it's there's a function assigned to it, the has function itself, but it's curried. So this basically isn't doing anything. The whole point is that it's using hasPath and passing just one value uh, as an array, and then the object to query. So the point is that has is actually just hasPath, um, and instead of multiple uh, properties, we're just passing the one, right? So like you can always have a list of one thing. So yeah, has is just hasPath. And then if we look at hasIn, there's all this mess. First, it checks if the object is nil, which I believe is null or undefined. And then we just return false. We just abandon the function. But the whole point is it's just calling its prop in object. It's using the in keyword. So that's why they call it has in. So, I mean, the implementation of has and has in is just like, almost nothing. Has path is a little bit more involved. I'm just going to show it to you, but I'm not going to go through it. Uh, it's doing some null checks and temporary assignments, and then we're doing a while loop while the path, which is the array arguments, yada yada. Yeah. Anyway, this you can figure this out if you care, um, but it's basically just drilling down and looking at things. So yeah, so that's has in and has path. And the only other one is head. So I'm going to go and knock that out. And of course, head is a list thing, a list function. So let me just clear out that stuff. And we have this list right here of x's. The head simply gives you the first element of the list. Um, Not a lot of mystery here. So r.head, and it just takes one argument, the list, and it's going to give me a one. You know, Nothing to it. Um, the only thing about this is that one of the original contributors to Ramda created something called Sanctuary JS, which I keep talking about. And the reason he did that is he ended up with a completely different mindset for what a library like Ramda should be. Ramda has like tons of these nice to haves, like that group with or collect by. You know, they're not really rewriting built-in JavaScript methods. They're adding things that are probably useful or common to a lot of cases. But the downside is there's like 250 functions that you gotta to learn, and it's like which one do I use, and am I using the right one? And it's hard to keep everything in your mind. The Sanctuary JS took the concept of we don't need all these things, but we do want to have these things called like options and maybe and either, like these monad things that I'm not going to get into now. But he brought up one of the things is that we want to have functions that are total functions. And a total function means that provided some input of the correct type, we should be able to get a value out, like a useful value, not undefined or null. But if we ask for the head of an empty array, we get undefined. So it's like any array, we can get the head, but there's this one case of an empty array where we get undefined. And then that means that we have to check to see if something's undefined, like with an if statement or some sort of guard. And that's where the idea of a maybe comes in, where instead of getting the, say, give me the first element in an array, it's saying, if you use a maybe type, you can say, give me, return a maybe of the first element. And that will give you back the string nothing, or not the string. It will give you back a nothing type or a just, and then the value of the first element. So don't worry about that if that's confusing. But my point is that Ramda is not perfect in all cases. It does not necessarily always provide functions that are total functions, which means provided some sort of valid input, we still may not get a result back. We might get an empty, like a null value or undefined. And if you look at the um, function signature, it tells you it takes a list of A's and returns either an A or undefined. So you can get both of those. Um, this also works on strings. Let's look at that too. Let's say the head of Bob, and we get a B, capital B. So that works on that. If you wanted the last one, there's a last function. Uh, we might as well go ahead and look at these because they're all so simple. And before I look at that, let me show you how simple the code is. This is basically the deal. We're using that nth function, which I don't think we've looked at. But nth is like the at method in JavaScript. It's just saying give us the value of the zeroth item in the array. And then so the opposite would be last. And we look at that, it's the exact same signature. It returns the last element. So if we did last, we get the lowercase b. If we did the last of x's, we get 8, which is the last element in this array x's. So that's two of the four, first and last. Um, the other one that's way more common is tail, and that just gives us everything except for the first element. So in an array, the first element is the head, the last one's the tail. I'm sorry, the head is the first element, last is the last element. I mean, that's pretty straightforward. And tail is everything except for the first element. So these guys here. So we look that up uh, to hit save. There we go. Um, so that's the tail. And then the last one is a knit. It's all of the elements except for the last one. Always found that to be a strange name because a knit, I think like initialize or something. But anyway, one, two, three, blah, 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 all the way through 8. I have two eights. Let me get rid of that. Yeah. 1 through 6, and then it ignores the seventh. And if we look at tail and look at the code for that, uh, well, the first thing it does is it checks for a method called tail because you can override this with your own method. We're kind of ignoring those, but the key is this slice one to infinity. So tail just starts with the first element, not the zeroth, but the first, like 2, and then goes to the end. And then just to be complete, if we look at the code for init, same thing, but it just slices 0 to -1, which is the whole array except for the last one. And yeah, um, so we got a lot out of this one. Um, if we go back to head, yeah, that's all the H's. And then we also looked at tail, init, and last. So pretty simple. So the next one we'll dig into the eyes, and there's a whole bunch of eyes. It's going to take a while to get through them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yeah, 22 of them. And, a lot of them are is functions, which are predicate functions. And then, of course, one like the we'll get to very soon is identity, which is the simplest of all functions, but also one of the most necessary functions. So anyway, thank you for spending your time with me. Tell a friend, and I will see you in the next video to pick up or to start with the eyes.